Today we're going to talk about how to write polynomials in standard form. And in doing so, I'll explain to you what standard form is and why it's important. So let's begin with an example by looking at the polynomial 4 plus 5x cubed plus 2x. Now this polynomial has 3 terms, and you could actually write this down in 6 different ways. Let me write the other 5 ways real quick for you. So by writing the 3 terms in different orders, there's actually 6 different ways you could write this polynomial down. And so you may be thinking to yourself, is there a right way? Is there a wrong way for me to write this? And actually no, there's no wrong way to write this, but there is something that we call the standard form. And that's the way that if you follow certain rules, everyone will always get the same looking polynomial. They'll get the polynomial with the terms in the same order. So of these 6 ways of writing the polynomial, the one that's in standard form is this one. And so what I'd now like to do is explain to you what rules you need to follow so that when you write this polynomial, you'll write it in this form. This is the standard form. So let me just clean up real quick. So I've now hidden the non-standard ways of writing this polynomial, and let me just move this correct answer up to the top and then explain to you what the rules are. So looking at this polynomial, there are 3 terms, and I want to talk about the degree of each term. So let me come over here and make a table. The first column will be the terms, and the second column will be the degree. So the 3 terms in this polynomial are 5x cubed, 2x, and 4. Remember, each one of these terms is called a monomial. The degree of each term is the exponent of the variable in this case, because there's only one variable. So if you look at the exponent, that's the degree of this monomial. So the first term, 5x cubed, the exponent is 3, so the degree of this term is 3. Now let's look at the next term, 2x. We don't write the exponent for the x because it's 1. So there's a few rules like this in algebra where sometimes you write the exponent, sometimes you don't. Sometimes you write, a positive or negative sign, and sometimes you don't. I know it can be a little bit confusing, but there's not that many of these rules, and once you get the hang of them, it'll just come second nature. So the term 2x actually is the same thing as 2x to the first power. So when we raise the variable to the first power, we just don't write the 1, we leave it off. But since the exponent is 1, that means the degree of the term 2x is 1. Now let's look at the last term, 4. Because this does not have a variable attached to it, we call it the constant term. That's because it's just a number, it never changes. No matter what number you put in for x, 4 is just 4. And so it's called the constant term. But what's the degree of the constant term? You might think, well, there is no exponent, so let's just say there isn't a degree. But there's actually a few rules further down the math road why you want to give a degree to this term. And here's what we do. The number 4 is just a constant, but with a little bit of cleverness, you could say to yourself, well, any number to the 0th power is 1, and 4 times 1 is 4. So 4 is actually the same thing as 4 times x to the 0th power. And so when looking at this, you could say to yourself, well, the exponent here is 0, so the degree of the constant term is 0. Now you may be scratching your head thinking, okay, this is really bizarre, why would you even mess with this? And let me just give you one little motivation for why why we do mess with this. So it turns out that, when you get into a little bit of the fancier parts of math, that if you multiply 2 monomials together, let's call them mono 1 and mono 2, it turns out that the degree of the product is the sum of the degrees. Now I don't want to go down that road too far because it really is kind of a detour that is too much of a distraction. But I do want you to know that eventually you will see there's a very good reason why we say the degree of a constant term is 0. It's not just an arbitrary rule that you have to memorize. Eventually you'll hear more and more excited clicks in your head when you start to see that by having a degree to the constant term, a lot of the algebra rules and techniques that you learn just become easier to say. But let's put that aside and focus on the definition of the standard form. So we have this polynomial, 5x cubed plus 2x plus 4. This polynomial has 3 terms, 5x cubed, 2x, and 4. The degrees of each of those terms are 3, 1, and 0. So the definition of the standard form is actually simple. write the terms in order of degree from the largest degree to the smallest degree. So the largest degree is 3. That's for the term 5x cubed. So we write 5x cubed first. The term with the next smallest degree is 2x. So we write that next. And then finally, the last term has degree 0. So then we write the constant term 4. Now, when you look at this, there might be one little thing that can trick some people up sometimes, and that's because you may not have actually heard it said out loud. And that is, when you look at the polynomial at the top, there's not a plus sign in front of 5x cubed, but there is in front of 2x and there is in front of 4. So why is that? That's because when the first term of a polynomial is positive, we just leave the plus sign out. So now look at the terms over here. For each one of these terms, it's written by itself. And so we're kind of following this same rule, is that the first term, if it's positive, you just don't write the plus sign. If it's negative, you would, but if it's positive, you can just leave it off. So that's why in the table, you don't see any plus signs. In the polynomial that we wrote at the top, there are plus signs in front of 2x and 4, but not in front of 5x cubed. And to recap, the rule is write the terms from largest degree to smallest degree. So what I'd like to do next is look at another example, because we took a lot of time to go through all the little details of this definition. And now I'd like to look at one a little more quickly and focus on why there's a standard form. It's like, is this just so we can test you on it, or does it actually have a benefit? And it does have a benefit, and I'd like to explain that to you now. To understand why there's a standard form, let's look at another polynomial. And this one is going to be 3c squared plus 12 minus 9c to the 5th plus 7c. This polynomial has 4 terms, and there are actually 24 different ways you could write this polynomial. So let's say you're working on a math problem, and you came upon a certain polynomial that was important to this problem, and you're looking at it and you're thinking to yourself, I wonder what my colleague got. I'd like to compare my work with my colleague. So you go over and say, hello, colleague, what did you get? And your colleague says, well, I got 7c minus 9c to the 5th plus 3c squared plus 12. Okay, so the two of you said different things out loud. You read the polynomial out in different ways. You got 3c squared plus 12 minus 9c to the 5th plus 7c, and your colleague got something different. So did you get the same answer or not? Well, to find out if you got the same polynomial or not, you have to go term by term and see if both of you have the exact same term in your answer. So you would say, well, my first term is 3c squared. And your colleague will say, well, that's not my first term, but let me scan through and look. And it's like 1, 2, 3. Okay, my third term is 3c squared. So I have that term. And notice your colleague wrote a plus sign in front of it. You didn't, because 3c squared is the first term for you. Okay, so we can check that off the list. So now you go on to the next term. You said, well, the next term I have is plus 12. Your colleague goes through and scans the 4 terms, 7c minus 9c to the 5th plus 3c squared, and it's like, aha, I have plus 12 too. It's dangling there at the very end. You're thinking, okay, so far so good. 2 terms down, 2 to go. Then you say, well, I have a negative 9c to the 5th. How about you? And your colleague says, yes, that's my second term, also minus 9c to the 5th. It's like, okay, we're almost done. And then you say, the final term you have is plus 7c. And your colleague says, well, I also have a plus 7c. I didn't write the plus sign, it was the first term, but I also have a positive 7c term. So with a deep sigh of relief, you both realize that you have the same polynomial. Now this approach could all be avoided if both of you just wrote down your polynomials in standard form. Because if it's in standard form, you just have to go left to right once, comparing them term by term. If they're the same, you're done. You don't have to scan over your polynomials over and over and over again, comparing everything term by term. So let's see what the standard form is for this polynomial. Here we have 4 terms, and they are 3c squared plus 12 minus 9c to the 5th plus 7c. Now for each term, let's look at the degree. So for the term 3c squared, the exponent is 2, so the degree of that term is 2. Next term, 12, it's a constant. And remember, we talked a little bit about this odd thing about it being 0. The degree of the constant term is 0. The third term we have is negative 9c to the fifth. The exponent is 5, so the degree of this monomial is 5. And lastly, the last term in this polynomial is 7c. We didn't write the exponent, and that's because the exponent is 1, and when the exponent's 1, you can just leave it off. So the degree of that monomial is 1. Now we are going to write these 4 terms from largest degree to smallest degree. So the largest degree is 5, and that corresponds to the term negative 9c to the fifth. So that's the first term you want to write, negative 9c to the fifth. The next largest degree is 2. That belongs to the term 3c squared. Then the next largest degree is 1, which belongs to 7c. And then lastly, there's 12. So this is how you write this 4-term polynomial in standard form. So if you were in a classroom with 24 people, you included, we're not counting the teacher, they're just off in the corner there, and you were working on a problem and this polynomial was the answer, it's possible that if you did not use standard form, every single person in that classroom could have a different looking answer. They're all the same answer, they would just be the terms would just be in a different order. But if you all wrote this polynomial in standard order, then you would very quickly be able to compare your answer or your work with someone else and very quickly see if you got the same thing or not. So there you have it. The standard form just says when you write down a polynomial, arrange the terms so that you go from the largest degree to the smallest degree. And remember, the degree of a constant term is 0.